Hello and welcome to my channel. My name is Muhammad Mujtaba Alam and you are watching Ilm Academy. In today's video, we will cover a topic of measurement sciences which is pretty basic, that is significant figures, but you need a proper understanding. First of all, we must develop our understanding about digits and numbers. Let's suppose if I have a number like 5, 6 and 4. This is a single number, means it is one number and it contains 1, 2 and 3 digits. Simply, you can say that a number can have more than 1 digits. Now, you can also say that, or you must have to remember this, that a single digit is a number, but a single number is not a digit. Let's suppose if I write a numeral as 1. Now, this is also a digit and also a number, but you cannot say that 4, 5, 6 is a digit. It is not a single digit. It is a number. It is a single number which contains 3 digits. Now, moving towards our main topic, that is called significant figures. You can also say that significant digits, then it will not be a bad idea. Now, what are those digits or figures? They are defined as the reliable digits, means the digits on the behalf of which you can claim certainty, or you are sure about those digits, and the last one with uncertainty. And among those digits, what does it mean? That among those digits, the last digit or the last figure is uncertain. You are not sure about the last digit. Then those collectively, those figures or digits are called the significant figures. Now, let's suppose if I have a measurement of wait a minute. I have a measurement of 52 centimeters. Now, in this number there are 2 digits, 1 and 2. So I can say that I know this digit with certainty. I'm sure about the 50th position of this measurement, but I'm not sure about this second, means the 52nd centimeter. I'm not sure about that. So these two, this digit is known with certainty and this digit is known with uncertainty. So collectively there are 2 significant figures, or there are 2 significant digits in this measurement. Now, let us consider the explanation of this definition with an example. Suppose I have to measure a length of a wooden bar right here. Now, if I have a scale in which a centimeter is not further divided or graduated to the 10th place of a centimeter, as you can see, the only measurement you can do with this scale is only in the centimeters, and you cannot go beyond a centimeter. So it means I must have the reading here. Let's suppose this wooden scale ends in length here. According to the scale, this is 0. Let's suppose this is 0 centimeter and this one is around between 3 and 2 centimeter. Let's suppose it is 2.3. According to my assumption, the 0.3 centimeter is not mentioned here. I assumed the value of this measurement to be 2.3 centimeter. While in this measurement, I'm sure about 2 centimeter, but not about 0.3 centimeter. So I can say 2 centimeters is sure and 0.3 centimeter is not sure. So together I can write the measurement as 2.3 centimeters, in which 2 is non with certainty. Certainty means it's certain, and 3 is uncertain. Okay, so how many significant figures this measurement has? 2.3 has 2 significant figures, because according to the definition it contains at least one certain measurement and one uncertain. So the last digit is uncertain and at least one digit is certain. That is according to the definition of significant figures. Now if the scale is graduated also in millimeters, that is 1/10 of a centimeter, I can get the measurement, as you can see here, to be somewhere around 2.32 centimeters. Now this is a different case while I'm dealing with the same length. In this measurement I'm sure about 2 centimeters and 0.3 centimeters, but not about 0.02 centimeters. That is the 100th place. As you can see in this illustration, 2.32 centimeters. So according to the definition, I know this digit to be certain and also this to be certain, as I can see the calibration of the scale and measure it with this calibration, but I'm not sure about this 0.02 centimeter, that is the 100th place of this measurement. So this one is uncertain. So again, according to definition, significant figures are those digits in which at least one of them is known with certainty and the last of those digits is uncertain. So I have the last digit as uncertain and the 2 digits to be certain. So this value contains 3 significant figures. Now here are some rules. Those are actually 5 rules. Those are very easy to keep in mind to determine the significant figures if you're not encountering any you can say measurement. So you don't have to always go to the laboratory and check whether the scale is really graduated to be precise or accurate. So number 1 is all non-zero digits are significant. What does it mean? You can see in this examples, I wrote it in the green. Number 1 is 64. There is no any zero, so it has 2 significant figures. Second one is 542. It means it is a number 542, and according to digits it contains 542. None of these digits are zero, so it has 3 significant figures. Next point is zeros placed between non-zero digits are significant. What does it mean? Let's suppose consider this simple example, the second one. There are 1, 2 and 3 zeros. The digit 0 is placed 3 times between 2 non-zero digits. 2 is not a zero digit, and also the last one 2 is not a zero digit. So this rule says if zeros, no mention how much they are, so tens of thousands of zeros, if they are placed between a non-zero digit, even single non-zero digit, all of those zeros are significant. And it also paves its way for the decimal point, even if the decimal point is in between. So you also have to you obey the rule. So this value contains how many significant figures? two of the non-zero digits, that is 2 and 2 significant, and the 3 zeros also included in this way. So we have 5 significant figures. In this value, although we have a decimal point in between, but this rule says you don't have to look for the decimal point, but you have to look for the zeros locating between the non-zeros. So it has 1, 2, 3 and 4. So it has 4 significant figures. Next is zeros relating to the value less than 1 are non-significant. What does it mean? To simply, it says that any value which starts by 0 point, any value which starts by the 0 point is a value smaller than 1 or less than 1. So any value which includes zeros in a value which is less than 1 are non-significant. It means that this value, because it starts by a 0 point, 0 and a decimal point, it must be a value smaller or lesser than 1. So I must have to say, according to this rule, it only has one significant figure, and all those zeros are not considered to be significant. So it contains one significant figure, and this value also contains two significant figures. And this value, the first two zeros are according to the third rule, that is, the value is smaller than 1. So those values are coming to the left of the value, so we are dealing those zeros according to the rule 3, that is, they are not included in significant figures. But this value, this zero, is according to the second rule, that is, any zero which is coming between two non-zero will be considered as a significant. So it contains actually 3 significant figures. I hope you enjoyed this point, because it is a little tricky. Let's suppose we can go on with another example. Let's suppose if I have a value 0.070809. So in this value, these two zeros are not going to be considered as the significant figures, because they are not significant figures according to the rule 3, that is, those are the left zeros, you can say claiming for the values lesser than 1, and those zeros will be considered as significant because those values, those zeros are significant according to the rule 2, that is, those are coming in between the non-zero digits. So it contains 1, 2, 3, 4 and 5 significant figures. Now the fourth rule is also very simple. It says final zeros to the right of the decimal point are significant figures. Here is a decimal point in this value, and here is a decimal point in this value, and these are the final zeros. So those zeros will be considered as significant. So it in total it has 1, 2, 3 and 4 significant figures. And this value also contains how many zeros? 2 zeros. So those are considered to be significant. 1, 2, 3, 4 and 5, those are considered because those are non-zero digits. So it contains 5 significant figures. Next rule is also interesting. This is the most important one. It says zeros relating to the value greater than 1 are not necessarily significant. What does it mean by 1? Because 1 is a unit quantity. Okay, so it is also mentioned that those are not necessarily significant. Means to say, you can say it, say those zeros to be significant at some point, and you can also deny those to be significant at some points. So you can also answer this question to be that it contains 1, 2, 3 and 4 significant figures, and at the same time you can say that it only contains single or you can say one significant figure. Same is the case with this value. It has two answers. It means that you can say that it contains 4 significant figures, 1, 2 and 3 and 4. You can also say that it has only 2 significant figures. The problem is that whenever you are counting a number, you can say the 10th or the 100th or the 1000th and going on, if you're considering that to be unit quantity, let's suppose if I consider every 10th value to be a unit, every 10th value to be a unit, then each zero which is you can say representing the 10th value, the zero of this value will not be considered significant. Let's suppose if I'm talking about some measurements, let's suppose I have some measurements 10, 20, 30, 40 and 50. Now all the measurements are in 10th, you can say 10th, you can say order. Either you cannot say that 15 is existing between them. So here the zero is not significant because we are dealing the value of 10 is a unit, so it contains only one significant figure here. It also contains one significant figure and so on. But let's suppose if I'm talking about values to be 10 centimeter, let's suppose some measurements I have 15 centimeter, then I have 17.2, then 25, then 30. In this case you can say that we are not dealing the 10th value to be a unit. We're not dealing with it. So here it contains two significant figures, it also contains two significant figures, and same is the case with the 30, it also contains two significant figures. I hope you understood this concept, especially the fifth one. It varies according to the measurement values. I hope you enjoyed the videos, and for which topic you are desperate beside me that I can upload the video for, you can also mention it in comments. I will upload the video for that. And after all, if you like this video, press the bell icon and subscribe button, and like this video and share this video as much as you can to support me, that I will ever present myself in your highness. So up to next time, goodbye.